Hello, I'm Fatih Sezgin and I'm going to talk about my engineering project, which is machine learning's approach to stress detection and recognition. First of all, I have used a Jupyter Notebook, which is an open source project that allows us to run Python code separately from each other and mostly used for machine learning, image processing, or deep learning projects. And I have used Python 3.7. And first of all, we are starting with importing the libraries that we have used in the project. The red labels indicates that there are some deprecated libraries but that's okay for us. That should be okay. And after this, we are using a FiSioNet dataset that has located in the file system or the root system of the project, and uh, with the WFDB library we can convert the systems, we can convert the files that has the dot extension, which is binary, and to the human readable format as a arrays, and the metadata about the signals that we have been read. So we can see the metadata about the signals that we have take the data set, and we can see some of the signals are missing, like the less than 7 signals that the drivers, and some other information about the units of the signals and signals length and the frequency of samples. And this code cells like using the for the visualization of the signals, like the whole drive faces that driver 5 has been drawn. This can be seen the the full of the signals. And we have also another uh, file called time intervals CSV, which comma separated value extension, like the these values show in which minute each driver changes segments like phases, and we are dropping the final rest phase because the drivers are most likely to be relaxed in the final rest phase. And for creating the new baseline for the uh, values of the starting point of the each phase, we are setting the initial rest as a 0 and adding up the previous phase and the next phase time with each other. We are create a new baseline, and we can see the in the project references there is a table that has been already calculated for us the mean duration of with standard deviation of for phases time, and we approximately add these times to our time sample, and we have the final uh, final phases, the time of the phases. And as we have discussed before, some signals were missing, so we are deleting these signals, and we have only the signals that we can use are length of 10, and these are the feature names and descriptions about our features that we will be extracting from the data. For this, I have written a code blocks like the method, a function, the calculated feature, which takes a driver node and the sample time. I will describe this later. We have started the code blocks. There is, as you can see, there is no output, but the purpose of this to recognize the function to the Jupyter notebook, and the calculated feature is used here. As you can see, the described before, the statistical features are created here, and as you can see, a stress level creating here. And for each driver, we are using the driver, we are passing through as a parameter to calculate statistical feature as a driver number, and the face of the drivers, the face of the drivers as a parameter, and these automatically calculates the features like the standard deviation of the respiration for each phase, for initial rest as in our case, and the mean HR or other description of the features are calculated. As we can see, these are compressing the file, but as we can see, we can see the other statistical features all calculated and labeled as stressed for using a reference. After that, we can see the correlation matrix, and we can say that the strength of the correlation has the standard deviation of EMG and the root mean square of EMG. These are the most related to have the stress, and to train the data set, we are dropping the stress column and assigning into the X, and we are assigning Y to the stress column to have the stress labels, and smoothing the X and Y to have the most accurate system. And we can see that after the smoothing, the shape of the X will be how that has changed, and the normalized also, the Y values will be normalized. And after that, we are using the lazy classifier, which tries to mostly use machine learning algorithms and tries to find the best for us, for our features that we have extract. And as we can see, our training, the shape of the X has increased, like, and as we can see, the perceptron model has a balanced accuracy like 93%, which is a little bit high, and follows the Bayesian classifier to 85%, and these machine learning algorithms has the accuracy of 93% of balanced accuracy with our extracted features. So the project is pretty much about this, and thank you for listening to me.